Hi everyone. Today we're going to talk about this topic, which is magnetic myths. So, my name is Vijin Venu. I'm a PhD candidate in experimental quantum optics at University of Toronto. So, the things that I'm doing at my research is kind of related to magnetic fields, but today we're going to talk about magnetic fields and magnetic things in general. So, as growing up in India, we hear a lot about magnetic fields. So we hear about magnetic energy, we hear about things like magnetic energy, magnetic wave, or electromagnetic field. And one thing specifically that I heard growing up was magnetic fields are something that can affect us. So the Earth has a magnetic field, and it can have effects on us that can cause health problems or things like that. For example, this is a newspaper article that came up in a Malayalam newspaper, Malayalam Manorama, a few days ago, which basically tells you that you should never sleep pointing your head towards the north. So, okay, there's something that all of us hear. And we also have these health blogs or fitness websites, which tells you that there is scientific evidence that you should never point your face towards the north while sleeping. So what is the truth there? This is someone that we all know. He has many videos floating around YouTube or any other social media platform. According to me, he's one of the big sellers of pseudoscience in India. He's kind of like a wholesale dealer. So he also talks about magnetic fields. So he says you should never sleep facing north. So there's a famous video of that on YouTube. And then there are things like this. So then there are blog articles which tells you that there is a center for Earth's magnetic field, and that's apparently located in India. And it says that it's actually located inside a temple or something. This person is familiar to the Malayalis in particular. So she's a cardiologist in the United States, and she claims that she made a video regarding the Sabrimala issue recently, and she claims that women should not enter temples during their periods because that could cause health problems because of the magnetic fields in temples. So these are all things that we hear about from India about magnetic fields. And then if you search with keywords such as magnetism or religion or spirituality on Google in general, you have a lot of blog articles coming up which relates anything and everything to magnetic field. So they're not done with the Earth magnetic field. They also go to solar magnetism, for example, here. So Hinduism today says solar magnetism is something that that's related to astronomy or astrology, or spiritual magnetism, and so on and so forth. So in this talk, we are going to see what magnetic field is and how things create magnetic field, what is Earth's magnetic field, and we're going to specifically see if magnetic field or Earth's magnetic field can have any effect on human beings, or can it have any bad effects on our health. So before we start, I'll give you a quick introduction to the magnetic field or the physics of these things. So we'll start with sort of like a 12th grade level introduction to electromagnetism, and then we'll go on to see how that helps us in understanding what magnetic field actually is. So beginning with the idea of charge. So electric charge is something that is very fundamental to matter. So matter has electrons and protons. So electrons are negatively charged and proton is positively charged. And when we rub together things, so electrons usually get transferred from one object to the other, that actually gives a charge to objects. So that's electric charge. Now, we have seen this effect in our real life. There is actually a force between charged objects. So the things with the same charge will tend to repel each other, and the things with the opposite charges attract each other. And this force is called the Coulomb Force. Now, let's assume that there is a charge sitting right at the center of the screen. Now, if I keep another charge near it, that charge will feel a repulsion in this direction. Now, if I keep another charge here, that charge will feel a repulsion in this direction, because these are both positive charges. So in general, because this charge is sitting right at the center, if I keep any charge around it, that will feel a force. And the direction of force is shown like this using arrows. And this is called electric field lines. So electric field lines are showing the direction of something called electric field, which is a property around the space that is containing this charge. So this charge, because it's sitting there, it gives some property to the space around it, because of which if I keep a second charge somewhere else, that second charge will feel a force. So this is called electric field. So the idea of field in physics comes from this. And electric field is a measurable quantity. We can measure this quantity for the space around the first charge. This is electric field. So similarly, if you have a positive charge, if you keep another charge around it, it'll repel from the positive charge. If you have a negative charge, you'll get a positive charge. If it's just kept around it, will get attracted to that negative charge. So that's the direction of electric field. So electric field is a vector quantity. It is a quantity that the space gains from having a charge in space, and it has a direction. Now, there's something called electric dipole, which is a combination of a positive and a negative charge. So if we keep a positive charge and a negative charge next to each other, there's electric field around it, which is going from the positive charge to the negative charge. So that tells you what force a positive charge sees when we keep it near this configuration. So it's an electric dipole. So next we'll come to the main topic of this presentation, which is magnetic field. The idea is very similar here. So we have all seen a bar magnet, which has a north pole and a south pole. So this is a magnetic dipole. It has two poles, which are magnetic poles. So if I keep another south pole near the north pole, it'll feel an attraction. And if I keep another north pole near the south pole, north pole near the north pole, it'll feel a repulsion. So that means I can define a quantity around this magnetic dipole, which is called magnetic fields. And that actually gives you the direction of the force on a magnetic north pole around this magnet. And this is, again, a measurable quantity that the space acquires near a magnet, and it's measured in units of Tesla. So Tesla is some unit that might be new to most of us, because we don't usually talk about this unit at all. So Tesla is the unit in which magnetic field is measured. Now, how can we create magnetic fields? So we can have magnetic fields in two ways in general. So if we have a bar magnet, there's a magnetic field around the bar magnet, which has the direction as I showed you earlier. It goes from the negative, shows from the north pole of the bar magnet to the south pole of the bar magnet. Also, if you pass current through a wire, then that also creates a magnetic field. And the direction of magnetic field is as shown here in this picture. So this is what we see in electromagnets. So suppose if we take a nail, and if we connect a wire through the, if you wrap some wire around the nail, and if we pass the current through the nail, then whenever you turn on the current, the nail acts as a magnet. Whenever you turn off the current, it's no longer a magnet. So that's called electromagnetism, or that's called an electromagnet. So the nail acts as an electromagnet because wires carrying current can produce magnetic fields. One more concept, which is electromagnetic induction. That says when you have a dynamic magnetic field, that means when you change the magnetic field in a particular location in space. What that means is, let's say I take this magnet, which has both north pole and south pole, and I actually move this magnet into this tube, which has a wire wrapped around it. So that changes the magnetic field around this metallic loop, or this metallic wire, and that creates a current in the wire. So whenever we have a changing magnetic field in a region, if there's a metallic object there, that will acquire a current due to the changing magnetic field. That is the reason why people are asked not to, people with pacemakers are asked not to go to regions of high magnetic field, because pacemaker is like a metallic device, and it works with electric signals inside. So if you go into a magnetic field region, that might change the magnetic field near the pacemaker. That might induce some currents in the pacemaker, and that could damage the pacemaker working, and that could be dangerous to the person himself or herself. So that's why magnetic fields could be problematic to people with cardiac pacemakers, high magnetic fields. Now, all matter in nature is magnetic. This comes down to the fact that I just told you earlier, is that if there is a motion of charge, if there is a current basically is motion of electric charge, that creates a magnetic field. Now let's take an atom. So an atom consists of a positively charged proton and electrons moving around. So in a simple model like this, we can think of the electrons moving around the atom. Now, because the electrons are moving, that has an electric current associated with it, and that creates a magnetic field. So every atom has its own magnetic field. So every atom is a tiny magnet. So depending on how atoms are arranged in materials, they could either respond to a magnetic field strongly, or they could not respond to a magnetic field strongly. Depending on that, we can classify materials whether they are magnetic or into different types. So the first type is ferromagnetic material. So ferromagnetic materials are materials like iron, cobalt, or nickel that has a strong attraction to a magnetic field. So pure iron, if you take, that is a ferromagnetic material. So they'll get attracted to a magnetic field, for example. There are other materials which are called paramagnetic materials. They don't have a strong attraction to magnets. They have what we call a weak attraction to magnets, and we don't really see it like in real life. If you take a paramagnetic material such as aluminum, you'll see that you don't see an attraction for aluminum towards a bar magnet. So that's because it's a paramagnetic material. It's a weak attraction. You have to apply very strong magnetic fields to actually see this effect. There are other materials such as diamagnetic materials. They also see a weak repulsion. And this effect is also very tiny, so that in general, we call the paramagnetic and diamagnetic materials as non-magnetic materials. So as I said, iron is a ferromagnetic material. That doesn't mean everything that contains iron is a ferromagnetic material. For example, if I take iron oxide, that need not be a ferromagnetic material. So it depends on how iron atoms are arranged in a specific substance to decide whether it's ferromagnetic or not. Now, coming to magnetic field strength, as I told you, magnetic field is something that we can measure, and we measure that in the units of Tesla. So how much is 1 Tesla? It's a question that we can ask. So we don't really have an idea. So as people who might not be doing physics, people may not have an idea of how much a Tesla means, how much a Tesla is. So for example, we know how much a kilogram is, how much a gram is, how much 100 kilograms is. I mean, we can have an intuition of that because it's something that we are using on a day-to-day life. But magnetic field is not something that we use on a daily basis, and that's exactly something that people who propagate pseudoscience use to propagate misconceptions about magnetic field. So let's look at what magnetic field strength means. So how much a Tesla is. So in Netherlands, they used 16 Tesla magnetic field to actually levitate a frog in air. So this was done in University of Nijmegen, and it was done about 10 years ago. So a frog was levitated in air using 16 Tesla magnetic field. The frog was alive during this experiment, and the frog also lived after the experiment, and the frog probably died its natural death. So frog didn't seem to have any problem with the 16 Tesla field. We've all seen MRI scanning machines. So we take brain scans with MRI, and the amount of magnetic field that's used there is roughly 1.5 Tesla. Could vary between 1 to 2 Tesla, but that's kind of how much 1 Tesla is. 1 Tesla is the amount of magnetic field in an MRI machine. We have seen fridge magnets. So the magnets that we stick to the fridges, they have a magnetic field strength of 0.005 Tesla. That's 5 millitesla, and that's about 1,000th. That's 1,000th of the MRI scanning machine magnet. So that's a smaller magnetic field. So the fridge magnets cause an even smaller magnetic field than the MRI scanning machine. Makes sense. Now, as I told you, cardiac pacemaker, the people having cardiac pacemaker should be careful when they're in the presence of magnetic field because of the effects it can have on the pacemaker itself. So the suggested exposure limit for cardiac pacemakers is 0.0005 Tesla, which is 10 times smaller than the refrigerator magnet. So what that means is people with cardiac pacemakers should be a little bit careful when they're actually playing with magnets and so on. Now, Earth has a magnetic field. We'll talk about this in greater detail later on. So Earth has a magnetic field, and at the equator, the value of Earth's magnetic field is 31 microtesla. So that is 0.000031 Tesla. And that is about 1 million times smaller than the strength of an MRI. So about 100,000 times smaller than the strength of an MRI machine. So it's a much smaller magnetic field. So it's a very, very, very small magnetic field. So the Earth's magnetic field. Now, as I told you, current carrying wires can act as magnetic field sources. So if you have a high power line, if you stand like 30 meters from that high power line, if you measure the magnetic field there, that's about 2 microtesla. That's 10 times smaller than the Earth's magnetic field. Now, human brain has a magnetic field. Don't get me wrong there when I say this. Human brain has a very, very tiny magnetic field. This is because all our muscle activities are controlled by currents that are traveling, ion currents that are traveling from the brain to the muscles. And this current is a very small current. It's very hard to measure it. And that creates a magnetic field which is 2 nanotesla. A nanotesla is 1 billionth of a magnetic field. So you can see how many zeros are here to that magnetic field value. So it's like an extremely tiny magnetic field. And the measurement of this magnetic field requires like very sophisticated instruments. So it's really hard to measure. Now, can we measure magnetic field? So you might have thought, so already that as I told you different magnetic field values, it might be really hard to actually measure magnetic fields. That's true. So to precisely measure the magnetic field, very tiny magnetic fields, you need like very sophisticated instruments. But you can actually do that with a smartphone. Now, how that works? So these days, you have smartphones and you have apps like Google Maps or Apple Maps. And if you're at a location, if you're using GPS, you can see your location at a particular place on the Earth. But you can sort of see like a blue dot. But with the blue dot, you also see some direction. So you can the map can also tell you what direction are you facing. Are you facing towards the west, towards the east, towards the north, or south? So that's made possible using something called a magnetometer inside the smartphone. So it's a small chip that can actually measure Earth's magnetic field and tell you what orientation are you having with that phone. Now, this magnetometer in the phone can be used to measure magnetic fields. And for this, you need third-party apps. One of them is, Google apps or third-party apps. So one of them is called Google Science Journal. I would highly recommend this app for doing fun experiments, fun physics experiments. So we can do various other things with this app. And with this, I tried to measure magnetic field here in Toronto, Canada. And what I could measure just in an empty space or with nothing magnetic around, I could measure 60 microtesla, which is kind of like the magnetic field in northern region, which is regions like Toronto, Canada. They have 60 microtesla magnetic field, which is a really tiny magnetic field, 2 times the magnetic field of the equator, so which is 0.00006 Tesla. Then what I did, I took like a earphone, the normal earphone that we used to listen music. I took that and I brought it near the magnetometer, and then the magnetometer shows 311 microtesla. So which is a magnetic field which is roughly 5 times the magnetic field due to the Earth. So your earphones themselves can produce a magnetic field 5 times larger than the Earth's magnetic field. I took another kind of earphone. So these are Bluetooth earphones, and there's a tiny magnet there to stick it to itself so that it doesn't fall off from your body. And I took that Bluetooth earphones and I brought it near the magnetometer of the phone. And then I could measure 4K microtesla of magnetic field. How much is 4K? It's 4,000 microtesla. So the actual value is 0.004 Tesla or 4 millitesla. So this magnetic field, as you can see here, is 70 to 80 times larger than the Earth's magnetic field itself. And this is something that you used to hear music, so you don't have any problems using that. Okay. And you can use this app. You can use the magnetometer in your phone to measure magnetic field anywhere. You can go to temples or churches, or you can go to any place and try to measure the magnetic field there. And you can convince yourself if there is anything supernatural or anything supernatural magnetic field there. That's something that you can convince yourself with. So technology has gone so far ahead that things like magnetic field are also measurable these days. That's the point that I'm trying to make. Now, as I told you earlier, Earth is a giant magnet. So the reason is that it's as if there is a huge bar magnet inside the Earth. So here you can see this dashed line. So this line represents the Earth's rotation axis, and there's a magnet inside the Earth which is aligned sort of at an angle with respect to the rotation axis of the Earth. And that magnet has its north pole at Earth's geographic south pole, and the magnetic south pole is at Earth's geographic north. So as a result, Earth magnet will produce a magnetic field which is going from south to north. That is something that we make use of in navigation using compasses, because compass north pole points to Earth's north, because that's where it's feeling an attraction to. So the compass north pole is actually pointing towards Earth's north pole, which is actually a magnetic south pole. And the reason why Earth has a magnetic field is because of like some currents or ion currents inside the Earth, especially in the Earth's outer core. There are currents that produce the magnetic fields due to the Earth. So as I told you earlier, also the Earth's magnetic field is such a tiny magnetic field. It's only 31 microtesla, and it's very small compared to like a lot of devices that we usually use in daily life. Now, this is a map I've taken from Wikipedia, which tells you how the Earth's magnetic field intensity changes on different parts of the Earth. So Earth's magnetic field originates, it's more concentrated towards the poles, and it's lesser as you go to the equator. So which is clear here. So near the equator, the magnetic field due to the Earth is about 30 microtesla, and as you go towards the poles, it increases, and it can go up to 60 to 65 microtesla, or even sometimes 68 to 70 microtesla. It's only a tiny difference. It's still 70 microtesla, and that's not a huge magnetic field. That's like a very small magnetic field compared to, for example, a fridge magnet. So, but my point is still there is a variation of magnetic field on the Earth's surface. There's another thing called inclination. So magnetic field is a vector quantity. It has a direction, and depending on the place you are on the Earth, magnetic field lines could be either parallel to the Earth. That's true for region near the equator, and as you go north or south, magnetic field could have an angle with respect to Earth's surface, and that exact angle is called inclination. So here you can see a green line, which is called the magnetic equator. So that's the place, if you go there, the magnetic field to the Earth will be exactly parallel to the surface. So it's kind of like adding, some sort of symmetry to the Earth's magnetic field, because Earth is a sort of a sphere, and if you take a sphere, there is no center to that surface, spherical surface, right? So because it's a magnetic field coming out of from the south going to the north, there's no center that we can define for that spherical surface. All you can define is an equator, which is a line that passes through the middle of the Earth. Now, if I zoom that into India, you can see that this magnetic equator is actually not passing through India. It's actually not even so close to India. It's actually going through Indian Ocean. It's actually passing to Sri Lanka, but it's completely outside India, and it's not at all passing through India. And it's not a center point, it's a line. It's an equator line. That's where people are claiming that Earth's center point of magnetic field is located in India. So first of all, there is no such point as center point of magnetic field due to the Earth. We can define an equator line, and that line is not even situated in India. So people claim various things. There are blogs about various things. The center point is in India, it's inside some temple. These are all wrong facts. These are all like absolutely wrong. Okay, so let's now come to the newspaper article. It's in Malayalam. So it's written here that you should be afraid of magnetic fields due to the Earth, and because of that, you should never face towards the north while sleeping, because the Earth's magnetic field originates from the north, and it'll end at the south. So people who can read Malayalam can read this line, which is underlined here. It originates from the north and ends at the south. Is that really the case? No, it's not really the case. The thing is, the Earth's magnetic field is actually coming from the south and it's going towards the north. So it's completely opposite as to what they claim. So it's obvious that they don't really have any idea of what they're talking about. Okay, so this was written by someone who's apparently an astrologer with the newspaper. So let's come to the big fishes. Let's come to what they're actually saying here. So this is the video that I talked about earlier. So this wholesale dealer is now saying as to how Earth's magnetic fields can affect us, and because of that, we should never sleep with the head facing towards the north direction. So the first thing that he says is these continents, like you have the plates. So you have the Eurasian plate, you have the African plate, you have the continents. They're all getting pulled to the north because there is magnetic north pole in the north, and they're getting some effect due to magnetic field, and they're all getting pulled to the north. Okay, is that really true? First of all, Earth's magnetic field is only really tiny. It's 31 microtesla. It cannot give any force to large land masses like this, and that's also clear from here. There is no specific direction to the continental drift. So if you go back to about 100 million years, and if you look at how the Earth's plates have moved so far in the past, you can see that they're moving in all sorts of directions. For example, South America is moving to the southwest. India is moving to the north. Things are moving to the south, east, west, all sorts of directions. So there's no particular direction in which all places are moving. So that means the continents are not getting affected by magnetic fields. And magnetic fields is so tiny that it cannot really put any effect on big things such as continents. Okay, so that's something very wrong. Next, okay, there's iron in the blood, and because there is magnetic field, the magnetic field will give a pull to the iron, because as we all know, iron is magnetic. Okay, sounds correct as the first sight, but is that really true? It's true that there is iron in the blood. Hemoglobin, if you look at the molecule that has iron, so here you can see that there's iron sitting in the middle of hemoglobin. But the problem is, hemoglobin is not magnetic. So hemoglobin comes in two types. There's deoxyhemoglobin, there's oxyhemoglobin. Deoxyhemoglobin is paramagnetic. Oxyhemoglobin is diamagnetic. So if you look at these articles, it'll be clear to you. So hemoglobin as a molecule is not a magnetic molecule. So it cannot feel the attraction due to magnetic fields. You need extremely high magnetic fields to attract paramagnetic or diamagnetic materials. And Earth's magnetic field is such a tiny number, it's 31 microtesla, so it can never give any force of attraction to hemoglobin. So also, so Earth's magnetic field as measured here is 60 microtesla, and if you keep a headphone, it's 4,000 microtesla. So if this were true, if by some chance hemoglobin was being attracted by magnetic fields, if you keep these earphones, that should result in blood coming out of your ears. So that's not happening. That means hemoglobin is not magnetic. It's not a magnetic material. Blood cannot feel any attraction due to magnetic fields. So one of the greatest misconceptions about magnetic field and blood is that blood has iron, and that's why it gets attracted to magnetic field. And this is being propagated again and again by so many people to prove their pseudoscientific claims. So this just disproving this claim that blood gets attracted by magnetic field is enough to actually disprove, I think, 80% of this magnetic field claims or myths. So okay, let's move on. So the next thing that he says, by the time I couldn't watch the video anymore, he was saying that if you go to the south hemisphere, if you go to places like Australia, New Zealand, or Brazil, you should not point your head towards the south. In south hemisphere, you can actually point your head towards the north. But that itself is contradicting the first thing that he said, which is, I don't know if he realized that or not. Within the 15 minutes video, he actually contradicted himself, which means he has no idea what he's talking about. Okay, let's move on. So there's no point wasting time on this video anymore. Okay, let's come to the next video, which is more popular among Malayali community, is about temples and magnetic field. So this doctor apparently in her scientific video claims that the temples are situated in magnetic fields. Yes, temples are situated in magnetic fields just like anything else on this planet. So everything on this planet is situated in magnetic fields because Earth has a magnetic field of 31 microtesla, and this is a map of Earth's magnetic field. So let's, for argument's sake, assume that she didn't mean Earth's magnetic field. She probably meant about something more than the Earth's magnetic field. So Earth has a magnetic field which can vary in different places of the Earth. That's it's lower near the equator, higher near the poles. Okay, maybe she talked about this. So the anomalies in magnetic fields due to rocks and minerals and things like that. So this is called a magnetic anomaly map in geology. So this, for example, is a magnetic anomaly map of South India, which has these red regions, which has a higher magnetic field compared to Earth's magnetic field, those regions, and the blue regions where there is a lower magnetic field compared to Earth's magnetic field, those regions. So that anomaly is because there are rocks or there are minerals that could be magnetic that are present in these regions. But how much is the anomaly? Let's look at that. The anomaly is only like 200 nanotesla in this region. A nanotesla is 1 billionth of a magnetic field. So it's such an extremely tiny variation due to magnetic fields that is coming from huge rocks or mineral deposits. So if you go to any temple, you cannot have any magnetic field which is more than a few nanotesla. So that's my point. So most of the people claim that temples have some sort of magnetic field because of the rocks or the metal that is there. That's completely not true, because rocks or metals cannot produce a magnetic field which is over a few nanotesla, and a nanotesla is 1 billionth of a Tesla. Such a small magnetic field, and therefore temples don't have any special magnetic fields. And for example, this is South India, and if you put any dot, any dot at any point on this map, that could be a temple. So that itself proves that there is no special magnetic fields at temples in any place in South India. Okay, so this is another map of magnetic field anomaly of Canada, which was easily available than that of India because it's a official document provided by the Geological Survey of Canada. And here you can see that the magnetic field anomaly due to in different parts of Canada is much higher than that in India. It could be about 20 microtesla, but that itself is really small. So that's only half as much as Earth's magnetic field in this part of the world. So again, Earth's magnetic field anomaly is extremely tiny. That's my point. Okay, so then she talks about various other things. Okay, first of all, the claim is the priest apparently gives a life force to the idol, and then there are like the energy bodies, or human body has an energy body or things like that. And apparently, she claims that medical science hasn't understood these things so far. So I don't know. All I can say to that is this is something called Krebs cycle, which I learned in 12th class biology. And this basically tells you how energy is produced in human body. It's well understood by medical science. Okay, I'm not a medical professional. I'm someone who does physics. So yeah, that's all I can tell you. I'll just go on to the next grade. Okay, the important claim here is that the menstrual flow becomes upwards due to the magnetic field at the temple. Okay, there's menstrual blood. When blood can never feel a force due to magnetic field, and magnetic field can never cause the blood to flow upwards. This is already proved. So blood cannot be attracted or repelled by magnetic field. Okay, what she might be talking about is this thing called retrograde menstruation, which is a condition that's there which is very common in most menstruating women. So this research article says that it's a very common physiological event in all menstruating women with patent tubes, and medical science has found reasons for the possible reasons for retrograde menstruation. It could be increased hormone production. It could be uterine growth. It could be obstructions in the cervix or vagina. It could be contraction. So these are all the reasons that could cause retrograde menstruation, and magnetic field is not a reason that cause retrograde menstruation, because blood cannot get attracted by magnetic field. Okay. Okay, so then other things. There are so many things to talk about in this regard. So there is magnetic therapy. People claim that if you wear magnetic rings, so if you wear rings made of alnico, aluminum, cobalt, nickel alloy, that can cause, that can make the blood flow more smoothly, and that would help you in case of muscle contractions and all. That's not true, because blood cannot be attracted or repelled by magnetic field. But blood is a non-magnetic material. So many things to talk about. So, okay, so it's very impressive how much time and energy do they put into propagating this pseudoscientific claims. They have these label diagrams which clearly shows how the blood is clotting when there is no magnetic ring and when the blood is flowing freely. It's very impressive, but it's all incorrect and absolutely not true. Okay, now towards the last, I'm coming to the last few slides on my talk. So I'll be talking about magnetic fields. So I'll be talking about this question of whether magnetic field can be harmful to humans or not. So the first question is, are magnetic fields harmful to humans? Second question is, can human beings sense magnetic fields? Okay, the question is, can magnetic field be harmful to humans? It depends on the intensity. It's like if I keep a 1 gram object on top of my head, I won't feel anything. I won't feel a pain or anything. But if I multiply that by 1,000,000, if I make it 110, I might as well die by just keeping a huge mass on top of my head. So that's the same thing with magnetic field. Earth's magnetic field is such a tiny number. It's 31 microtesla near the equator and 60 microtesla near the poles. No effect on human beings. Human beings are not at all affected by Earth's magnetic field. If you multiply that by a 160, you'll get the strength of a refrigerator magnet. That could be problematic to people with cardiac pacemakers. Normal people don't have any problems. If you further multiply that by 300, you'll get the strength of an MRI scanning machine, which is 1.5 Tesla. People normally get MRI scannings for like 15 minutes under this much exposure. They don't have any problems. The magnetic field, even a strong magnetic field such as 1.5 Tesla cannot cause any problems to human beings. Okay, so let's go to World Health Organization website, what they recommend as the tolerance level for magnetic field. So WHO recommends that a person moving in a field about 2 Tesla could have sometimes nausea or some metallic taste in the mouth or some issues like this, because moving in a magnetic field is more problematic, because that would cause electromagnetic induction. That's problematic. Heart functioning can be affected with magnetic fields of more than 8 Tesla, which is, by now you must have realized how huge a magnetic field that is compared to that of the Earth, which is about 1 million or 10 million times that of the Earth's magnetic field. The recommended occupational exposure limit is way above the Earth's magnetic field. It's about 200 millitesla. So 0.2 Tesla is the recommended Earth's occupational exposure limit. The recommended public exposure limit is 40 microtesla, still much higher than the exposure Earth's magnetic field. So people, even WHO thinks that people moving in 40 microtesla need not have any possible health problems. So it's then that these pseudoscientific gurus are coming to us and telling us you should be afraid of the Earth's magnetic field. So that's not true. Earth's magnetic field cannot have any effects on us. So the last part of my talk is, can human beings sense magnetic fields? So this is an area of active research. It's called magnetoreception, whether living organisms, where they can sense magnetic field or not. We have found bacteria, which are called magnetotactic bacteria, which can actually align themselves to the Earth's magnetic field. So that's one thing that people have found. And another thing is, birds, for example, use magnetic fields for navigation. So we have found that pigeons, for example, they use Earth's magnetic field for navigation. But the problem is, people have been researching on this for more than 50 years now, and they haven't been able to find an organ inside a mammal which could actually sense Earth's magnetic field. So now comes the question whether human beings, whether we can get any kind of magnetic field sense, whether we can sense magnetic field. Is there magnetic field reception in human beings? So several people have looked at this. So there is this group at Caltech. What they're trying to do is to figure out whether magnetic fields can provide any sort of stimulus to human brains. So it's a very controlled experiment. It's not pseudoscience. They're trying to see whether magnetic fields can affect, or whether can it give any stimuli to the human brains. So the details about this is available in a Veritasium video. Veritasium, as you might already know, is a very famous YouTube channel about science or physics, and there are lots of interesting videos to watch there. I would highly recommend the channel there. So they talk about this experiment. So this group is now trying to find out whether human beings have a magnetic reception. Okay, so if that was something that made you wondering whether there could be some issues or some influences due to magnetic field on human brain, I would let you watch the last part of this video that I talked about here. So I'll let you watch the last part of the YouTube video where the researchers themselves talk about what this research actually means.
This study does not show that magnetic fields have some kind of special influence on you, that they don't cure disease, they don't make you smarter. You can't communicate telepathically or something through them.
So these are the types of emails that Connie does not want to receive. Just so everyone's clear, in case you've got sort of a crazy idea.
Okay, so to conclude my talk, we have seen how small Earth's magnetic field is, how tiny a value that is compared to even fridge magnets, and how it cannot have any effect on human beings because it cannot attract blood, or it cannot have any effect on human beings. So the bottom line of this talk is magnetic fields are something that we should not worry about, especially the Earth's magnetic field is something that we should not worry about. And there have been so many things that is existing in our culture, which is making use of this pseudoscientific claim that Earth's magnetic field can affect us. So I hope this presentation can help you understand what really magnetic field is and how much effect can it have on human beings. Okay, so thank you very much for your attention, and that's it.